So for this one, we're going to use our skills at factoring to help us get some more points. So we used a table of values in the first example. This example, we're going to say, well, I know this is odd and positive, so it's going to go up like this as a line. And if I can factor this, then I'll be able to find the x-intercepts. And let's say I find those three x-intercepts. And I know it goes up like this, then I'll know my graph has to do something like that. Again, I won't know how high my maximum is or how low my minimums are, but having the x-intercepts and having the general shape, I'll be able to sketch it somewhat correctly. So let's look at how we factor this one. Normally, with an x cubed, you would look at the last number, the constant term, and then see which are the possible factors. This one's even nicer because there's an x in each one. And since there's an x in each one, you can start by taking out that common factor. And so we don't have to do synthetic division. If you want to see the one that they have in their example, goes through a process of having to do the synthetic division and factoring it completely. This one off to the side, you can use your factoring skills from last year. There's a common factor of x I can take out. Then I'm left with a quadratic, so I can factor that further. Minus 6, so we'll go plus 3, and minus 2 will give me a plus 1x in the middle. And so if I wanted to figure out my zeros, I know I'm going to have a 0 at x equals 0, a 0 at x equals minus 3, and a 0 at x equals 2. So I know those are three of my points. And I know the general shape of my graph. So I know that it's coming from down here, is going to go through there, back through there, and up again. And on a non-calculator part, this is all that would be expected of you. You've labeled your x-intercepts clearly. You do not know how high this is going to go, and you don't know where it's going to reach that point. If you wanted to get even more accurate, you could add some values with the table of values. Like you could plug in minus 1 and see what actual value comes up. You could plug in positive 1 and see what value comes up. Positive 1 is easy to do mental math. 1 plus 1 minus 6 is negative 4. So this point here is at 1, negative 4. But I don't know if that's the maximum or not. It might dip down before negative 4 and then go up, or dip down after. I can't tell. Just because it's perfectly between 0 and 2 does not mean that it necessarily has to have its minimum at that point. Just out of curiosity, we'll put it up on our graphing calculators to see what it actually looks like, and we'll see if that minimum is actually at negative 1, or sorry, at 1, negative 4 or not. So we have x cubed plus x squared minus 6x. X cubed plus x squared minus 6x. There's a graph. So I was curious about that minimum, if it actually happened at 1, negative 4. So I'm going to just calculate my minimum between 0 and 2. No, it was at negative 4.06 and at 1.12. It was close, but not exactly. And it would make sense that if it's swooping down, the idea might be that it's close between the middle of those values, but we can't say that for sure. My graph compared to this one looks like the peak is a lot higher than I drew. But with a non-calculator part, we're just getting a sketch. We got the basic shape of it, and we've labeled our x-intercepts. And so that is fine. Questions you can do for this one are 7 and 13.